There are a number of common questions about rocket launch sites. Why aren't there more launch sites? Why don't we launch rockets from mountains? Why are the launch sites in areas that flood so easily? And why does everybody want to launch from Cape Canaveral? Our subject is rocket launch sites, and specifically, what makes a good launch site. The whole point of a rocket is to put a payload into a specific orbit, so we'll need to talk a bit about how orbits affect launch site selection. If you want a lot more information on orbits, go and watch my Space, You Know Orbits video. The first principle is that closer to the equator is better. There are two reasons for this. The first is that the Earth is rotating towards the east. At the equator, the speed is 1,038 miles per hour, or 1,670 kilometers per hour. If we launch to the east, that rotational velocity is added to the velocity of the rocket, and that means more payload to orbit with a given rocket. As we move away from the equator, the velocity decreases. 20 degrees of latitude north or south, and the velocity is 6% less, and it's 23% less at 40 degrees, and 50% less at 60 degrees. The second effect depends upon the kind of orbit you're targeting. Orbits that go directly around the equator are called equatorial. Other orbits are at an angle to the equator, and they spin sometime north of the equator and sometimes south. The angle to the equator is known as the inclination of the orbit. Because of the way the physics work, the inclination of the orbit you can easily reach is equal to the latitude of the launch site. Cape Canaveral is at 28 degrees north latitude, so launching directly east gives an orbit that is inclined at 28 degrees. A higher inclination orbit can be reached from Cape Canaveral by aiming the rocket to the northeast, and it can also be reached by aiming the rocket to the southeast. Higher inclination orbits result in slightly reduced payloads. For launches to low Earth orbit, it's technically possible to reduce the inclination during or after the launch, but it costs so much energy that we generally say it's impossible. A rocket that could lift 22 tons to a 28-degree orbit can only lift 4 tons to a 0-degree orbit. This isn't generally an issue, as low Earth orbits that are low inclination aren't really very useful for anything. For orbits that are on the way to geosynchronous orbit, where zero inclination is very useful, it's possible to get there from higher latitude launch sites, but it has an energy cost and therefore a payload cost. Most of these payloads launch to an intermediate geosynchronous transfer orbit, and the satellite does the rest of the work of getting into the final orbit. If we are heading to a typical geosynchronous transfer orbit, like GTO-1800, we'll say that a hypothetical rocket launched from the equator will have a payload of 6,500 kilograms. Launch that same rocket from a launch site at 28 degrees, and it only lifts 5,500 kilograms. It's about a 15% reduction in payload. Significant, but not so bad that you can't launch a geosynchronous satellite from that launch site. Move to 51 degrees, and the payload is down to 4,000 kilograms, about a 40% reduction in payload. Those two reasons are why launch sites near the equator are generally preferred. There are exceptions that I'll cover later. Many launch sites are on the East Coast, so the expended first stages can land in the water. Cape Canaveral in the US, Rocket Lab LC-1 in New Zealand, and Satish Dhawan in India are all on the East Coast. All three areas are lucky enough to have good East Coast locations. Europe, on the other hand, is less lucky. They don't have any convenient East Coasts for spaceports that wouldn't drop used stages on other countries. The European Space Agency therefore launches from Guiana Space Center in French Guiana on the north coast of South America. This location is also only 5 degrees from the equator, which makes it a great site for low inclination launches. Russia does have an eastern shore, and they do in fact have a spaceport near that point. Vostochny Cosmodrome. It's at 51 degrees north, so it has very limited access to lower inclination orbits. The Soyuz 2 rockets that it launches are manufactured in Samara, more than 6,400 kilometers away by rail. The first launch at Vostochny was in 2016, and it has only launched a few rockets. The main Russian launch site is at Baikonur in Kazakhstan. It's at 46 degrees north, but launching directly to the east means that the spent rocket stages would drop on China or Mongolia, so launches from Baikonur aim a little bit to the north, and that means their minimal orbital inclination is 51 degrees, the same as their new launch site at Vostochny. The limited inclinations accessible from Baikonur is one of the reasons that the International Space Station orbit is inclined at 51 degrees. It's a little less efficient for the US to launch to that inclination, but it's pretty impossible for Russia to launch to lower inclinations, at least in low Earth orbit. Because of the location of Baikonur, it does mean that Russia drops used rocket stages over their own territory, but given how hard it is to get to their eastern coast, it's an understandable decision. China does have an eastern coast, and in fact the Wenchang launch site is nicely situated at only 19 degrees of latitude. That is, however, one of their new sites. Their most active launch site, and the one that supports crewed launches, is Jiuquan at 41 degrees of latitude, and that's why their space station is also at 41 degrees of inclination. The spent stages from that launch site, and from their other inland sites, do fall on Chinese territory, sometimes hitting towns. If you're launching into polar orbits, you don't need an eastern coast. You can launch either to the north or to the south, and the latitude of your launch site is largely unimportant because you don't get a boost from the Earth's rotation. The Russians launch from Plisetsk all the way up at 62 degrees, and the Swedes are planning to launch from Kiruna at 68 degrees. Most of the US polar launches come from Vandenberg Space Force Base in California, where launches are made over the water to the south. There are often some constraints on launching. Guiana Space Center is nice because it's largely free of constraints, and launches can point directly east to head to low inclination orbits, or north or past north to get to polar orbits. Cape Canaveral is more restricted. It can't get higher than 57 degrees because it would fly over the eastern seaboard of the US, and if it tries to aim too far south, it will fly over islands with people on them. It's possible to fly what is known as a dogleg trajectory, one that is deliberately curved to avoid flying over land. This is one that SpaceX has used to launch from Cape Canaveral into a polar orbit. That path keeps them offshore Florida and puts the drone ship in a reasonable position for the first stage to land. India has similar problems with their launch site, and they also fly a dogleg when going to a polar orbit. Not surprisingly, dogleg trajectories are suboptimal and reduce payload slightly. There are other factors that make a good launch site. It's very useful if it's not close to anything. Cape Canaveral is well separated from the mainland, with NASA's Launch Complex 39 to the north, Cape Canaveral Space Force Station to the east, and Kennedy Space Center in the middle. The closest non-spaced areas are Titusville in the west, more than 10 miles from the big NASA pads, and Port Canaveral to the south. This pattern is repeated at India's Satish Dhawan. There are pads near the coast, solid rocket manufacturing in the same area, and pretty much nothing nearby. SpaceX managed to find a pretty good site at Boca Chica on the east coast of Texas, just north of Mexico. The launch pad is near the coast, and the closest built-up areas are the Starship factory location and what is left of a small retirement village. There's really nothing else around. But if we zoom out a bit, we see South Padre Island to the north at about 5 miles of distance, and Port Isabel just a little bit farther. This is an area that is not used to rocket launches, and Starship is a very big rocket, so currently SpaceX is limited to 6 launches per year from this site. The launch site has to be a site where you are wanted. The left picture shows the distribution of the population on the East Coast, and you'll note that the east coast of Florida is population dense, which means launch sites are limited. Cape Canaveral is a set of barrier islands that were low-lying and swampy, and therefore they were available when the government was looking for land to test missiles. Far to the north in Virginia, there is Wallops Flight Facility, also a piece of land that is away from population centers. Camden County in Georgia attempted to create a spaceport near Woodbine, Georgia over a number of years, trying to attract NASA and more recently SpaceX, but in 2022 voters rejected the project. Your site needs to be accessible enough to get your rockets and equipment to the site. A Falcon 9 is pretty much the maximum size rocket you can put on a truck and ship across the country. It's about 3.7 meters or 12 feet wide. It's very thin as rockets go. Other rockets are much bigger. The Saturn V was 10 meters or 33 feet, and the SLS core stage is slightly smaller at 8.4 meters or 28 feet. Both of these rockets are shipped to the launch site on a barge, and having water access at the launch site is therefore a useful thing. Or you can decide to build the rocket in a factory right next to the launch site, as SpaceX is doing with Starship, Blue Origin is doing with New Glenn, and Rocket Lab is doing with Neutron. You do obviously need a site for the factory, and a practical way to transport the rocket to the launch site if you're going to go with this approach. It needs to be permissible to build whatever launch infrastructure you need. This picture shows the construction of Pad 39A at Kennedy Space Center in 1965. In those days, there were no issues with taking 160 acres of wetland and filling it all in to create a launch site. In current days, there's a huge review process to do anything in sensitive areas. SpaceX went through it with their Boca Chica launch site. Rocket Lab went through it with their launch site in New Zealand. It generally takes many years of work and a lot of money to undertake such a project, and approval is not guaranteed. In most cases, it's far more straightforward to find a spot at an existing launch location, where the previous construction has paved the way for new use, and the surrounding population is used to the impact of rocket launch. These locations are of course desirable for many launch companies, with sites at Cape Canaveral difficult to get and sites at Vandenberg Space Force Base in California even harder to get. If you want to understand more about the history of Cape Canaveral and what companies are currently operating there, see my video, Launches at Cape Canaveral, Then and Now. Your rocket is going to need consumables, liquid oxygen and a fuel such as liquid hydrogen, liquid methane, or the refined kerosene known as RP1. You'll need suppliers for all these products in the quantities you require. Being near a site that already has that infrastructure makes it cheaper. For example, Air Liquide already has a liquid oxygen production facility near Kennedy Space Center. And now, you know launch sites. If you enjoyed this video, you might enjoy the Atlas of Space Rocket Launch Sites.